We're continuing our discussion of 7.3, W substitutions. Perfect. X minus 3 times the square root of x minus 4 equals 0. I'm going to let W equal the square root of x. So when I square both sides, I get W squared equals x. I replace, so I have W squared, that was x, minus 3 times W minus 4 equals 0. I try to factor. So I need them to multiply to be negative 4, and then I'm going to add the negative 3, so negative 4 plus 1. Set each piece equal to 0 and solve, so I get W equals 4 and W equals negative 1. But I didn't ask for W's, I asked for x. So I have the square root of x equals 4, and I have the square root of x equals negative 1. So continuing our discussion from before, we'd like to know what doesn't work before we have to check the check set. So right now, I know that the square root of x equals negative 1. That means the square root of something equals negative 1. That's not going to happen. The square root of x is going to be a positive number. So right away, I know that doesn't work. Like I said before, if you didn't do that, if you squared both sides and you got x equals 1, and then you plug back into your original, you would have 1 minus 3 times 1 minus 4 equals 0. And then you would see it doesn't work. Negative 2 minus 4 is 6, not 0. All right, so on the other one, a lot of people see the square root of x equals 4, and they're like, 2, my answer is 2. Right, you got to be careful though. If the square root of some number equals 4, if you square both sides, you see that's not 2. Square root of x squared is x. 4 squared is 16. So your answer is actually 16. You go back and check, you get 16 minus 3 times the square root of 16 is 4. Minus 4. 16 minus 12 minus 4, that does equal 0. So that one does work. All right, now the next one can be a bit intimidating. You see x plus 1, that's 5 over 2 plus 6 times x plus 1 equals 1 half, etc. All right, we want to write everything in the same order. So I have 5 over 2, then 1 half, then 3 over 2. So we have 3 over 2 and 1 half positions. So x plus 1 to 5 over 2 plus minus 5 times x plus 1 with 3 over 2 plus 6 times x plus 1 to 1 half equals 0. Right, so x plus 1 to 1 half, that's going to be my W. Now you could do this a lot of different ways. You could actually pull out an x plus 1 to 1 half and then let your W be something else. And I told you earlier, usually the easiest thing to do is let it be whatever something is to the smallest power. All right, so let's see how everything's related. I need a 3 halves power like that. So if I'm going to get a 3 halves power, I need to cube both sides. So I would get W cubed equals x plus 1 to 3 over 2. If I want a 5 over 2, I'm going to replace everything to the fifth. So this isn't quite like the normal ones we've had in W squared. All right, so let's see what's going on. We have W to the fifth minus 5W cubed plus 6W equals 0. So when we factor something like this is we have a W in common. So let's go ahead and pull a W to the front. So W to the fourth minus 5W squared plus 6. That can be really mean and make you use another W substitution. So you can make a new variable, call it U. And you could let U be W squared. But I'm not going to, we know how to factor things like this. So I can do a W squared with W squared. That's going to be what multiplies W4. Right, I need my numbers to multiply to be positive 6 and that would be negative 5. So I'm going to negative 2 and negative 3. So I have 3 pieces. I have W equals 0. I have W squared minus 2 equals 0. And W squared minus 3 equals 0. All right, so if I add the 2 and take the square root, I get W equals plus or minus the square root of 2. And the other one, I get W equals plus or minus the square root of 3. But we didn't want W, we wanted x. So we plug back in. So I have x plus 1 to the 1 half equals 0. X plus 1 to the 1 half equals plus or minus the square root of 2. x plus 1 to the 1/2 equals plus or minus the square root of 3. We're going to get rid of the 1/2 power, so square both sides. So I get x plus 1 equals 0, so x equals -1. Square both sides. I left it as plus or minus because I knew I was going to square both sides. So positive squared is positive, negative squared is also positive. Square root of 2 squared is 2. I get x plus 1 equals 2, so x equals 1. Check the last one, so square both sides. So I get x plus 1 equals square root of 3 squared is 3, so x equals 2. Now if you check all three of these, all three will work. So I'll show you a trick. Now I was going to plug in, well, -1 is the easy one. You plug -1 in to each of these, you get 0 minus 0 plus 0 multiplied by equals 0. Sounds easy. Let's say I was checking 1. If I plug 1 in, so I plug a positive 1 in, positive 1 plus 1 is 2. So I would check 2 raised to 5 over 2 minus 5 times 2 raised to 3 over 2 plus 6 times 2 raised to the 1/2. I would put it in just like that in the calculator. When you put that in, you do get 0 out. Now the trick in your calculator is if you put this all in one input, then you can do second enter, and it will pull up that same input and you can edit it. So what I would do is then go through, and everywhere you have 2, put a 3. So that way you can check this x equals 2 as well. You check them, both 2 equal 0. So all three of those answers work out. Alright, I would recommend doing your homework with a buddy though. One of you checks one answer, one of you checks the other answer. So it doesn't take you forever to just do the check stuff. Alright, number 7. So I have x cubed plus 216 equals 0. So it says first factor of the sum of 2 cubes formula. So let's say we're back in algebra 1. So if I'm back in algebra 1, I don't know how to solve this problem. I'm just going to subtract the 216 from both sides. So this is the old way. I would have x cubed equals negative 216. Take the cube root of both sides. I get x equals the cube root of negative 216. Punch it into your calculator if you don't know. It's x equals negative 6. Right, that would be your one answer. You would be very happy for your one answer, and you would be done. Right, but we're in algebra 2 now. You can have imaginary solutions. So this one actually has imaginary solutions. If you don't remember your 2 cubes formula, if I had a cubed plus b cubed, that factors into a plus b. I would say drop the cubes, same thing, just drop the cubes. Then I square the first thing, so a squared is a squared. Multiply the two together, so I have a times b. Square the last thing, so square b. My signs are same, different, plus. So looking at my original sign was plus. So same sign, different sign, plus sign. So fun. I heard recently someone calls it soap formula. So the same, opposite, always plus. So same, always plus. Like that. I've never heard that before. Alright, so I'm going to try to factor this. So when I try to factor, 216 was 6 cubed, so that's my b. So I have x plus 6. Square the first one, so x squared. Multiply the two together, 6x. Square the last, 36. Same, 50 plus. The first one, when I set it equal to 0, that one's just nice. That's x equals negative 6. That's the one that we originally had. That's the easy one. This other one looks easy. You think you can factor it, but it actually doesn't factor. So when things don't factor, you don't just stop there. You use quadratic formula. That x equals negative b plus or minus the square root of b squared minus 4ac all over 2. So I get negative 6 to positive 6. B squared is 36 minus 4 times 1 times 36 all over 2 times 1. So this is 6 plus or minus. You multiply all that out and subtract, you get negative 108. divided by 2, which is 6 plus or minus. If you remember how we simplify radicals, one way it breaks into the biggest perfect square is 36. So it's 36 and 3. So 36 times 3 is what makes it negative, or makes 1 over. The negative, that pulls out as 9. So I have I times square root of 36 is 6 times root 3. So 6I root 3 all over 2. And then remember the 2 can go into both pieces. So it's 3 plus or minus 3I root 3. Okay. Even though it looks like one answer, those are actually two answers. I have 3 plus 3 root I, or 3I root 3, and 3 minus 3 root, I can't say 3I root 3. All right, the third answer is the negative 6. And those are all three of our answers. The last one we'll do really quickly. So the proton in a magnetic field follows a path in a coordinate grid modeled by the function. This is probably one of those W functions, so it's just saying the proton's moving more like a W. What are the x coordinates of the points in the grid where the proton crosses the x-axis? So at some point it's crossing the x-axis. So the x-axis is the x-intercepts. So I'm going to plug in 0 for y. The x to the 4th minus 2x squared minus 15. Now I won't make you do the W substitution on this one. You can. I will let you factor. And multiply the negative 15 and add the negative 2 to negative 5 and positive 3. Set each one equal to 0 and solve. So I'd add the 5. I'd subtract the 3. Take the square root of both sides, calculate the plus or minus. So I get x equals plus or minus root 5. And I get x equals, this is a negative, so it's going to be plus or minus I root 3. Now, since this is a story problem, like a real life problem, not really, but if this was a real life problem, it's just a plus or minus root 5. It's crossing the axis a little bit more than 2. So somewhere there, a little bit more, a little bit less than 2. I root 3, that's not going to be along the x-axis, so these are the two answers. Back to number 7.